My name is Becky Robinson. I work with the Princeton Review. I'm a master GMAT instructor, which means I teach not only students but the instructors on how to teach the problems. I have been working with the Princeton Review for 18 years and consider myself somewhat an expert not only on the GMAT but particularly on the math section of the GMAT. So what we're going to do today is share some of the strategies to work through the hard math on the GMAT. So what we're going to do today is first discuss what is hard math, and then describe for you the best approach for studying math in general and for hard math specifically. And then finally, we're going to work through several problems to give you some specialized techniques to work with the hard math. And at the end, of course, we've got some special offers for all of you who attended this session. So, first of all, what is hard math? When most of us think of hard math, we think of equations like this, things that boggled our minds before we were taking the GMAT. But the truth is, even though the top equation could be used on the GMAT, you don't really need it. And secondly, any equations that you haven't seen since calculus, that's not going to be on the GMAT either. So the GMAT doesn't ask you to memorize esoteric equations or work with symbols you haven't seen since calculus. The GMAT is actually math that you saw back in Algebra 1, and it asks you to put those together in a new way using logical problem solving. So what is hard math? Hard math is any problem on the GMAT that makes you feel like you've hit a brick wall. We've all read those problems. You look at them and you don't know how to start. You don't know what's going on. You might even have that quick intake of breath saying, oh my goodness, what have I done? That's what hard math is. It doesn't even matter what the content is. Instead, what matters is what's hard for you. And that's what we're going to focus on today. So, how do you conquer hard math? Well, first you have to understand how the GMAT is making math problems difficult. Like I said, hard math isn't dependent on content. Hard math isn't math that you've seen later in your math career. Instead, all of the math comes from basically that same area. So how do you make a math problem difficult? Well, first and foremost, more difficult problems on the GMAT have more steps. An easy math problem might have 1 or 2 mathematical steps you have to go through to solve. A hard math problem can have up to 6 or 7. So one of the things that makes math hard is having these multiple steps. Another thing they do is combine concepts. You might understand how to work a rate problem, and you might understand exponents, but when you get rate problems and exponents together within the same problem, people get confused. So that's one thing that they do. They combine the concepts and make you work with different concepts during one problem. What else do? They provide trap answers. And this is hard to label as a hard math problem. Really what it is it's a problem that they've made hard by giving you answers that are easy to pick. So we're going to go through some of those trap answers at the end, but know that the GMAT knows how you think, and they are waiting to give you answers that seem easier than they should be. Next is they test familiar content in unfamiliar ways. What does that mean? That means that the content stays the same, but they use words or methods that don't seem familiar to you. Maybe you've done rate problems before, but you haven't seen the way that they've tested them. The next is they test unfamiliar content. And believe it or not, for unfamiliar content, more often than not, they go even farther back into your math history. One of the pieces of unfamiliar content that I've seen lately is the concept of remainders. And to remember how remainders work, you would have to dig back into your second or third grade math, because after that you were working with decimals. So they test that unfamiliar content. So how do you study effectively for math in general and for hard math? Well, first and foremost, you have to understand the topics that the GMAT consistently tests. In a minute, we're going to give a list of most of those topics, but what you really want is to find somebody, a book, a prep program that really understands what topics are on the GMAT and what topics aren't. Because ultimately, you don't want to study things that won't show up on the GMAT, and you don't want to understudy and not have studied something that was going to be on the test, something like remainders. The next is really important. You have to develop a consistent approach that works with each type of problem. So, for instance, every time you see a ratio problem, what is the consistent way that you're going to work with that problem? Do you have a consistent way for adding fractions? You want to kind of create that factory feel to help preserve your energy and to preserve your brain power for when the problems get a little tougher. Then, practice, practice, practice. This is the part that everybody knows but nobody likes. You're going to have to spend lots of time running through practice problems. And when you practice, you want to make sure that you're practicing within that consistent approach. And once you've practiced and you feel comfortable in your consistent approach for each type of problem, finally, you want to gain some flexibility by adopting alternative solution techniques, so that you look at a problem and say, my consistent way of attacking it is this, but in a pinch, I would use this secondary technique. So what does that mean? Or what, I'm sorry, what does the GMAT test? What are those topics that are on the GMAT? Well, here's a list of the basics of them. The GMAT loves to test fractions and decimals, and you should have a consistent way of working with them that doesn't involve a calculator, because on the GMAT, you don't get a calculator for the math section of the exam. Also, exponents and roots, mathematical definitions, percents, factoring, basic algebra. Remember, we're not reaching into the abstract of Algebra 2. We're staying pretty much with Algebra 1. Geometry, which has quite a few formulas, but isn't the geometry of the proofs that you took in high school. Instead, it's more area and volume type geometry. Averages and rates, ratios, probability, and counting methods. Now, there's a few other topics that get thrown in there. This is certainly not an exhaustive list, although it's a fairly comprehensive list. So these are the things you need to develop that consistent approach. A consistent approach, I can't stress enough, is the most important thing to effective test taking. It is a constant way to do a problem based on the content of that problem. Again, if you have a particular type, how do you approach it? Consistent approaches help to eliminate errors and increase your speed on the exam. And that's ultimately what we want to deal with hard math. How do you approach that problem, and do you do it the same every time? Consistent approaches also free you up for dealing with oddities within the problem, small tricks or traps that the GMAT has put in for you. So what does a consistent approach look like? For instance, one of the topics is percent change. The idea of if something goes from one number to another, what is that percent change? This is a little different from percent. So the first thing you want to have in your consistent approach is the basic formula. Percent change is always equal to the difference of the two numbers over the original of the number times 100. Now, if every time you have a percent change, you go ahead and put that formula up, you have a consistent approach to dealing with it. But within percent change, the way they play with tricks and the way you have to put your thought in is what is the original. If you have percent increase, the original is the smaller number because the numbers went from smaller to larger, therefore you would have a percent increase. If you have a percent decrease, then the original is the larger number because numbers decreased or went from larger to smaller. And then finally, if you have a problem that involves time, where they give you years or they tell you days of the week or something like that, the original is the earlier number in time. So the consistent way to do a percent change problem is to put up the basic formula and think about which number is the original. Now, you may have a difficult percent change problem, but every problem will enter into this formula at some point in time. So once you've developed that, then it's time to do some flexibility. What does flexibility mean? Well, if I have this particular problem, if x squared plus x minus 6 equals 0, and x is greater than 0, what is the value of x? There's multiple ways I can go about doing the problem. One of the ways is to take the answer choices and plug them in to the equation they've given you above and determine which of the answer choices gives the result that they define. It's a very valid way of doing problems. It can sometimes be quicker, especially on algebraic problems if you're not as comfortable with algebra. So doing this method, all I've done is taken, for instance, the 0.5 and I've put it into the equation. I get 0.5 squared plus 0.5 minus 6, and I know mathematically that that is not going to equal 0. But if I put 2 in, I get 2 squared, which is 4, plus 2, so 4 plus 2 is 6, minus 6 equals 0. So this one's looking like it could be a perfectly valid answer for x. If I go through the other problems, I notice that none of them are equal to 0. So using that technique, I can go ahead and pick B, or 2, as my answer. But let's say the numbers were bigger or there's a problem with applying this approach. What's another way I could do the problem? By coming up with multiple ways to do the same problem, you develop some flexibility. So another way that you could do this problem, and the solution's all going to show up at once because right now this isn't an idea of showing you how to do, but more strategy, is to actually do the quadratic. If you notice that x squared plus x minus 6 is a common quadratic, you can reverse FOIL that into x plus 3 times x minus 2 equals 0. And then you can use the quadratic property that anything multiplied by another thing that equals 0, one of them must be 0. So that tells me that either x plus 3 is equal to 0 or x minus 2 is equal to 0. And therefore, x is equal to either negative 3 or 2. If x has to be greater than 0, which is one of the conditions of the problem, then once again, I get the same solution. You certainly on the test wouldn't want to do this problem two ways, But when you're working through your homework and trying to develop flexibility, one way to actively do that is to figure out 2 ways to solve each problem. If you do that, then so that's the basic idea on how to study math and prepare yourself for some of these harder math problems. First, define the topics that the GMAT tests. Don't overstudy and don't understudy. Know exactly what kinds of problems you're going to see on the GMAT and only work with those. Once you've worked with those, define a consistent technique to apply every time you see that type of problem. And once you have come to a consistent technique, add some flexibility to your approach by deciding 2 different ways to do some of the problems that you have. The more flexibility you have, the better that it's going to be. Flexibility, though, doesn't mean that you're going to abandon your consistent approach. If you prefer not to do algebra on this type of problem, your consistent approach would be the first one. The idea of picking answer choices and just plugging that into the equations. That will work every time. If, on the other hand, you prefer algebra and you love to work with quadratics, although I'm not sure how many of you there are out there, you would consistently use the second approach. But what this flexibility allows is that when one approach isn't working for whatever reason, the problem was made difficult, then you can use the other approach. So working through that flexibility along with consistent technique is the key to doing hard math. It's actually the key to doing all of the math on the GMAT, but it's really the key to conquering those questions that get harder as they're made more complicated by the GMAT test writers. So the next section of our presentation, I'm going to be presenting the way that Princeton Review uses this concept of consistency and flexibility to work through some of the several hard math problems. I'm going to be solving problems, but I don't want you to necessarily focus on the solutions. You can possibly pause the recording, maybe write the problems down to work through them yourself. I will give you a little bit of time to work through a problem, but the focus here isn't on actual solutions or concepts in math. Instead, the focus is on strategies and techniques. So let's jump in and look at our first problem. Now, first of all, I must apologize. The PowerPoint was not doing this slide correctly, but let's look at the problem, and for now, ignore the writing over here on the left if you can. The question says, a store's monthly sales total declined J% from October to November. If the store's total in December were equal to its total sales in October, by what percent in terms of J did the store's sales increase from November to December? This is a lot of problem to digest, and it's made even harder by the fact that the problem used J instead of some number. So how do we approach this problem that's made a little bit more difficult? The very first thing is don't do unnecessary algebra. If there's variables in the answer choices, you can plug in numbers to use the concepts of algebra without actually having to use letters. Those of you who weren't good at algebra in high school will be very glad to know that this technique consistently works whenever you have algebra. But how does it work? Well, as it says, it declined J%. So I'm going to pick a number for J. Really, I could pick any number from 0 to 100 because it's a percent. I've chosen 25 because 25, it kind of works easy with percents. And if the sales total declined 25% from October to November, I can then pick some numbers for October sales and November's. In this case, I've picked 100 for October, because that's another number that works great with percents, and 75 then is what I get for November, because a 25% decline from 100 would give me 75. The next sentence of the problem tells me that the store's total of sales in December is equal to its total sales in October, which means that December is also going to be 100. So now I know that I've got all of my numbers. By what percent in terms of J did the store sales increase from November to December? Now we get into this idea of using the words in the problem to recall formulas and to recall consistent methods of doing the problem. The words in this formula say percent increase. So automatically, when I see percent increase, I know that this is the formula that I get to put in. From the slide from the consistent way of doing things, we remember that formula. Percent increase equals the difference of the original times 100. So to get the difference is pretty easy. I just subtract November from December. But we have to think about which one is the original. They've given us two Q's, time, November to December, and they've also told us percent increase, which if you go back and remember, when you have a percent increase, the original is the smaller number. So I'm going to go ahead and put that in my denominator and multiply by 100. So ultimately my answer becomes 25 over 75 times 100. Now that doesn't look like any of the answers I have, but when you use the plugging in technique, picking numbers that make the problem easier, the next step is to go ahead and put those same numbers into the answer choices. So I'm going to go ahead and put 25 in wherever I see J. Now, for the sake of time and because of the magic of PowerPoint, I can put them all up at once. You would, of course, on the test do one at a time. But as you're looking through, you see that A can't possibly be correct because 25 is not equal to 2,500 over 75. And you look at the numbers and you find, whoops, that only D can be the correct answer. Now, algebraically, could you have solved it? Yes. And you may want to do that algebraically during a review period in order to develop some flexibility in your approach so that you have both algebra and plugging in as techniques to approach a problem like this. But what you do is you take this harder math problem and you use techniques and strategies to take it apart slowly, piece by piece, and it becomes a little less daunting. So let's look at another problem. Here we have slips of paper are numbered from 1,000 to 2,000. If one paper is selected at random, what is the probability of selecting a slip of paper with exactly 3 identical digits? At first glance, you may automatically know how to do this, at which point this might not be a hard math problem for you, but most people's heads start spinning a little bit. So let's take it apart piece by piece. First, let's look at the word in the problem that tells us the type of math we're doing. Probability. Now I'm going to use that word to go through my consistent technique, and the probability of one event is the total number of items that I want over all of the possible items available. That's my consistent formula for one event probability. So now I can take that apart And notice that the first number I want to get is probably the total number of things. So I have slips of paper from 1,000 to 2,000. This is a summation question of how many actual numbers are there from 1,000 to 2,000. Well, if you're a little unclear about the answer to that question, one math technique that can help to develop some confidence and keep you on the right track is to try a simpler example. So for instance, if I count from 0 to 10, if I start at 0 and go to 10, that gives me 11 numbers. So that means that if I start at 1,000 and go to 2,000, my total is going to be 1,001. Now, the actual mathematical way of doing this is to subtract the smaller number from the larger number and add 1. But if you haven't done that in a while or you're uncomfortable with this, you can use that simpler example to see what the approach would be. So there my total is 1,001 slips of paper. And what's my next idea is to figure out how many I want. And what I want are numbers with exactly 3 identical digits. That seems like a pretty tall order. How many of these are going to have 3 identical digits? Well, if naming all the elements in a set is going to take you a long time, you're looking at it and thinking, I'm not really sure. Most of the time what the GMAT is testing is some form of pattern. So you're going to have to look for a pattern within what they've given you. If I have 3 identical digits, and remember that the numbers all have to start with 1 because they're from 1,000 to 2,000, I'm going to have a number where I have 1,000 with 3 identical digits, maybe 1,000 or 1,222. Or I'm going to have where the hundreds digits change, or where the tens digits change, or where the units digits change. And so my pattern is going to give me 9 of each, because within the 100, I could also have 1222 all the way up to 1999. So that's where I'm going to have 9 of each of these different digit sets. I can't include 1, so I wouldn't have 10, but I would have 9 of each set. If I have 9 of 4 sets, that gives me 36 total numbers. But beware, did we forget a number? Yeah, remember that we're going from 1,000 to 2,000, so the only number that's allowed to start with a 2 is the 2,000. So don't forget that number. Notice I have 37 total numbers with 3 identical digits, and therefore my total is 37 over 1,001. Notice that this problem is made a hard math problem by combining counting with probability, having to identify a pattern, and then they add trap answers. For people who have forgotten that there is 1,000, that there is the number 2,000, they've given you B, 36 over 1,001. And for people who accidentally count as 1,000 numbers instead of 1,001, they give you 37 over 1,000. So you've got to be careful on these hard math problems to make sure you get through every set. And the answer is going to be C. All right. So let's move forward and look with another pattern. Remember, if you're not solving these as quickly as I am, don't worry so much about that. It's these bullet points down here that are the important takeaways from today's lecture. Alrighty. So here we have a rate problem. Car X and car Y are both traveling in the same direction along the same road, and car X is 60 miles ahead of car Y. Car X is traveling at a constant speed of X miles per hour, and car Y is traveling at a constant speed of Y miles per hour, where Y is greater than X. In terms of X and Y, how many hours will it take car Y to overtake car X? If your head is spinning, you're among the majority of GMAT test takers. The question is long, it involves variables, and it involves multiple rates. So, there are multiple consistent ways of doing this problem. There are variables in the answers, so we can maybe use plugging in. There's rate. But I'm going to walk you through one set. There are multiple ways of doing this problem. There's variables in the answers, so maybe you can use the plugging in technique. It's a rate problem, so you can use the algebra involved in rate. I'm going to walk you through one method of doing the problem. You can use that as flexibility or your consistent method. So with a difficult rate problem, the first idea is draw a picture of the problem to help understand it. So I've drawn my little yellow road here with my two cars, and I've shown that they are 60 miles apart. And I can kind of visualize now what's happening. This back car is going faster than this car. And I want to know when this car is going to overtake the next car. Well, once again, I could put in the rate formula and work from there, and that would be a perfectly valid way of doing it. But this time I'm going to work through the problem in a way that if you're a little bit confused, maybe you might try. So on confusing rate problems, first of all, we can pick numbers for X and Y in terms of their constant speeds. You have to make sure that, as the problem states, Y is greater than X. So in my problem, I have picked 50 and 80. They work well with the 60, and they will work. I can work with those numbers within the problem. 50 and 80 are not numbers you're required to pick, but they're good enough. Now, if you don't know how to set up the rate problems, sometimes it's helpful to ask what happens in an hour. So if car Y is going 80 miles and car X is going 50 miles an hour, what happens in an hour? Well, what happens in 1 hour is that car X will be at 110 miles. He started out 60 miles ahead, and then he drove 50 miles. So car X will be at mile 110. And car Y will be at 80 miles. So he started out at mile 0, he went 80 miles an hour, but he hasn't overtaken because car X is still ahead of him. But you can start to see how this problem is working. And you can see that in another hour, in that second hour, car X will be at 160 miles because he's traveled 50 miles further than his 110 he was at the first mile. And car Y will also be at 160 miles because he's traveled 2 hours at 80 miles per hour. Therefore, in 2 hours, Y will overtake X if these are my rates. Now remember that when you've decided to pick numbers, all you have to do is have your target answer, 2, and plug X and Y into the answer choices available. So here I've done that, and as you look through the problems, which one of these is going to equal 2? And only answer choice A will reduce down. 60 over 80 minus 50, which is 60 over 30, will give us 2. None of the other answers give us our target answer. So we've taken a hard rate problem and assumed that maybe you're not so good at rates. So instead of focusing on the rate way of doing it, we've moved to a more common sense. Draw a picture and ask what happens in an hour, and then use some plug-in numbers to help you avoid the algebra. All right? So let's keep on moving. I know these problems are difficult. Remember, the title of this is How to Conquer the Hard Math. So kind of shake it off a little bit, and let's take on another hard math problem. Oh, everyone's favorite, data sufficiency, right? What is the first thing you need to do in data sufficiency? In any data sufficiency problem, easy or hard, we need to ignore the statements and the answers as they're written. As opposed, we don't want to read these every time and try to figure it out. So within data sufficiency, we ignore those answers, and instead we use a consistent method. Here at the Princeton Review, our method is a flow chart based on the concept of A, D, or B, C, or E. We really don't have time to get into that flow chart today, but if you work with our tutors or some classes, you'll get that pretty darn quickly. So we're ignoring the answers in a data sufficiency question. And now we go ahead and read. C and D are positive integers. D is greater than or equal to 2, and CD is the square of a positive integer. What is the least possible value of D? On its face, it doesn't look like there's an easy concept. It doesn't say ratio. It doesn't say miles per hour or percent change. All it tells us is the square of a positive integer. So if the concept is not readily available, you have to remember the concepts that the GMAT tests consistently. And one of the concepts that the GMAT tests consistently without using specific words is factoring. So if you've got some big numbers and you don't quite know what to do with them, one good step to help you get started on the problem might be to factor those numbers. So we're going to look at statement number 1, which says that CD equals 99,225. What do I do with that based on the square of a positive integer? Well, let's go ahead and factor it. So how do we factor it? A good consistent method would be to develop a factor tree. Take each number and pull a factor out on each branch and develop a factor tree so that you get all of the factors. And you get that C times D is 7 squared times 5 squared times 3 to the 4th. So that is the square of a positive integer, because each one of these integers, there are 2 of them. There are 2 7s, so you have 7 squared. There are 2 5s, 5 squared, and there are 4 3s, so 3 to the 4th. And that's C times D. So if I want the least possible value of D, and D has to be greater than or equal to 2, then D has to be one of these integers I have here, and I could allow C to take almost all of the factors and leave D must be 3. So 3 is the smallest factor greater than 2 represented in this multiplication problem. What does that mean? Well, in data sufficiency, if I could solve the problem, then I know that statement number 1 is sufficient. And if statement number 1 is sufficient by itself, the only answers I have available to me are A and D. A and D are the only answers which include a statement that statement number 1 is sufficient by itself. So those are the answers that I would go ahead and put on my scratch paper. Then I'm going to move to statement 2. Be careful to look at it simply by itself and not include information from statement number 1. And it says C equals 33,075. So I'm going to use that looking at concepts that GMAT tests and the idea of big numbers, go ahead and try to factor them. And I'm going to factor 33,075, building that same kind of factor tree that I did in the previous problem. And then I can set up that C is 7 squared times 5 squared times 3 to the cube. Now, if I know that CD is the square of a positive integer, that means that each one of these numbers, I should be able to take the square root when I multiply by D. But if I take the square root of 7 squared, I get 7, so that's great. If I take the square root of 5 squared, I get 5. That works. But if I try to take the square root of 3 to the cubed, I get left with a 3 underneath. I get 3 times the square root of 3. So in order to make C times D a perfect square, or the square of a positive integer, D must be at least 3. And since we're looking for the least possible value of D, 3 is going to be our answer again. So we've come to the same answer, but we only use statement number 2 on its own. So what does that mean? Well, statement number 2 is sufficient, and within the realm of A and D, or B, C, and E, if A and D are my only options, D is going to be my solution to this problem. So, how did they make this particular problem hard? They didn't come out and say factoring. Nothing in the problem indicated you should start factoring right now. Instead, they hid the concept inside the words of squares of a positive integer. So remember that the GMAT doesn't test crazy concepts you've never heard of. If the concept doesn't seem familiar, go back to the common concepts that GMAT tests and say which one would fit in. When they provide you with large numbers, it's most often factoring. So go ahead and try to factor those numbers and see if that opens the door to being able to solve the problem. All right, so a few more, right? We've got our hard math helmets on. Let's keep going. So this problem, 2 minus the square root of 7 times 5 minus the square root of 3 times 2 plus the square root of 7 times 5 plus the square root of 3. This problem is hard because as people look at it, they think, well, if I FOIL out 2 minus the square root of 7 times 5 minus the square root of 3, I'm going to end up with a lot of crazy square roots. And a lot of test takers will look at this and start to panic a little bit. So what's our first hint on any hard math problem? Don't panic. Take a breath and realize that every problem on the GMAT is doable with basic concepts. So what might the concept be here? Reordering the equations to see that indeed it's not as crazy as I thought. I see a pattern or some common lengths. I've got 2 minus the square root of 7 and 2 plus the square root of 7. So what I want to do is move those and put them together. And then I've got 5 minus the square root of 3 plus 5 plus the square root times 5 plus the square root of 3. So another little pattern. And things start to seem like they may come out a little bit easier. But I'm still not at the end yet. The next thing is to look for commonly tested concepts. So when we multiply sets of two terms, what concept is the GMAT testing? Well, a lot of the times it's testing quadratics. And the GMAT likes certain common quadratics. So you could FOIL out this question using the quadratic concept of first, outside, inside, last, and work through that FOIL. Or you could recognize this as the common quadratic of x minus y times x plus y is equal to x squared minus y squared. So instead of doing all that foiling, we can just use that common quadratic to recognize that the answer is going to be 2 squared minus the square root of 7 squared times 5 squared minus the square root of 3 squared. So I've used that commonly tested concept of common quadratics, and I've made my life a little easier. Now, all it takes is to actually square those numbers. So 2 squared is 4, the square root of 7 squared is 7, 5 squared is 25, square root of 3 squared is 3, and I go through and just simply now do simple addition and then simple multiplication to arrive at the answer of negative 66. So you can see that if you set the problem up differently than the test provides it to you, sometimes the problem becomes a lot more doable. If you panic, you generally don't feel like you can create a new problem. So if a problem scares you, take a breath and see what you can do to work within the problem. And on this one, it was a common quadratic. Okay. So onward and upward into a few more tips on how to deal with hard math. Here we have a student has 4 test scores in a class. The highest score is 84. The lowest score is 74, and the median is 77. What must the student score on a 5th test for the student's average score over the 5 tests to be 80? So a lot of you might be recognizing that this is an average problem. They're dealing with averages. However, we're missing some information we might need for average. So what's a way to start getting into the problem and dealing with it? Let's read the problem one phrase at a time and see what we can do. A student has 4 test scores in a class. Well, one thing we can do is draw out the problem. So I'm just going to go ahead and draw 4 lines for the 4 test scores. Then it tells me that the highest test score is 84 and the lowest test score is 74. So I can go ahead and fill those 2 numbers in. Then we get to the part that's a little bit tougher. The median is 77. Well, yes, I know what that means, but we have to get a little deeper than I know what the word median means. Let's review the definition of the word we know to make sure we understand what median means to this problem. The median of a set, an even set, meaning a set containing an even number of integers, is the average of the middle 2 numbers. So now I know that 77 is the average of the middle 2 numbers, which means that the sum divided by 2 is 77. So if I multiply 77 times 2, I get that the sum of the second and third numbers is 154. Because 77 times 2 is 154. I don't know what those two individual test scores are, but I know that the sum of them is 154. And I know that the sum of all 4 tests is 312. So now it's saying, what's the student's score on a 5th test for the average of the score over 5 tests to be 80? I use my consistent method of dealing with average, and I set up the equation that the sum of the 5 numbers over 5 is going to be equal to 80. Now, I can multiply that 5 out of the denominator to find that the sum of the 5 scores is going to be 400. I know from the previous information that the sum of the first 4 tests was 312. So if the sum of 5 tests is 400, I have to subtract that 312 in order to find out what the sum of that last score is. And 400 minus 312 is 88. So I know that that 5th test must be an 88 in order to obtain an average of 80. And therefore, I know that C is going to be my answer. So, how did they make this problem hard? It's an average problem, and average problems are very doable as long as you understand the formula and that it's mostly about the relationship between the sums of the different averages. But they made this problem hard by giving you a gap in the information. You feel as if you need to know both of these scores, but they give you a different piece of information that you have to review the definition and figure out what that definition means to the two numbers. And you have to accept what they've given you. Here, they never give you the second and third test scores. They only give you the sum of them. But that's enough information to move forward and work the problem. So that's another tip. Just keep moving forward with the information that they give you. Don't worry that it's not enough. Know that all the problems on the GMAT are solvable and there is enough information, so it's just up to you to find it, and sometimes they've kind of hidden that information in unusual ways. So let's keep going on another data sufficiency problem. This problem, I want to focus on the strategies of maybe I don't quite know how to do it, or maybe I feel like I'm running out of time. But before we get there, let's remember that we don't want to deal with the answer choices in their verbal form. So I'm going to get rid of those. And now I have, if the average of W and X is H, and the average of Y and Z is K, what is the average of H and K? So we need to put up that information that we have from the opening statement. With averages, you want to write the average formula for each average separately. So we've got the average of W and X, which is 2 numbers, is H. So the sum over 2 is equal to H. And the average of Y and Z, the sum of Y and Z over 2 is equal to K. And it's asking me to solve for the value of H plus K over 2, the average of H plus K. So I've written up a separate average formula for each of the problems. And now I need to go into the statements one at a time. So the first statement looks pretty workable. It gives me the sum of all of the W, X, Y, and Z. How does that relate to my formulas I have here? Well, I can get rid, and most often when you're working with an average problem, this is your job, getting rid of this 2 in the denominator by multiplying it and saying that W plus X equals 2H and Y plus Z equals 2K. So if I add them all up, W plus X plus Y plus Z is equal to 2H plus 2K. And all I've done is I've combined both of those problems. If W plus X equals 2H and Y plus Z equals 2K, then all of those numbers added up equals 2H plus 2K. So if I know the sum of all of them equals 14, then in essence what statement number 1 is telling me is that 2H plus 2K is equal to 14. Then I can factor out a 2 from each side of the equation to find that H plus K equals 7. And if I know what H plus K is, I can put that into my solution and actually solve. I don't need to because this is data sufficiency and I'm just being asked if I have enough information to solve. So I do know what the value of H plus K is, therefore statement number 1 is sufficient, and I know that my answer choices are A or D. Now statement number 2, the sum of W and X is 2 greater than the average of Y and Z, but 2 less than the sum of Y and Z. This is a pretty confusing statement, and it's something that the GMAT likes to do. Put together a basically easy statement that's at least understandable and doesn't require a whole lot of manipulation to understand, with a statement that seems confusing and very highly algebraic. If you are running out of time, let's say this is one of your last few math problems and you want to make sure you get to the end of the test and you have to guess, the good guess is to notice that the easier statement compared with a more confusing statement, it's your best bet to assume that the confusing statement is more likely than not to be correct. Meaning, if I have an easy statement, which leads me to AD, and the second statement is confusing, if I have to guess, given time constraints or I'm just cannot do the algebra, my guess would be D. Now, let me show you alternately how D is correct. Let's see. The sum of W and X is 2 greater than the average of Y and Z. So let's write that out. The sum of W and X, so W plus X, equals 2 plus the average of Y and Z over 2. So I can write that equation out. But that same sum is 2 less than the sum of Y and Z, so it's Y plus Z minus 2. Now we have two equations that don't seem to work. They don't solve one for the other, but the tip that popped up a little bit early for me is down at the bottom. When two equations in the GMAT are equal to the same thing, your best approach is to set those two equations equal to each other. So we're going to knock out the W plus X altogether and make 2 plus Y plus Z over 2 equal to Y plus Z minus 2. So now we can manipulate this algebraically. Again, go through the algebra at your own will, or in your own time, but notice that we will solve it for y plus z equals 8. And then we can go back up to one of the formulas where they define w plus x and learn that w plus x equals 6. So now we notice that this information is basically giving us the exact same as the information in statement number 1. I can add 8 and 6 to get 14, and that is the sum of all of the digits of the w, x, y, and z. Since it's giving me the same information, I know I can go through the same process to get to the answer, which is why I now know algebraically that D is indeed my answer. But remember the guessing strategy of if you're stuck on a data sufficiency and you can deal with one of the statements, it's an easy statement, and it's paired with a statement that seems highly confusing or highly algebraic. Okay, so here we have another problem. A manufacturing company with 20 factories uses a letter coding system to represent each factory. If each factory is represented by either a single letter or by a pair of two distinct letters, what is the least number of letters that can be used to represent all 20 factories? Assume that the order of the letters in the code does not matter. Now, on its face, some people may make some assumptions very quickly about the problem. And there's some answer choices here which are designed to trap you. So be careful. Don't pick answers that repeat information from the question or that are simple calculations found within the question. What does that mean on this question? The number 20 is sitting there. There's 20 factories, 20 letters. That makes perfect sense. Gee, I can save some time and pick D. Or there's 20 factories, there's 2 letters in a code, maybe there's 40. Or, gee, 20 factories, I've got 1 or 2 letters, maybe I just divide the 20 by 2 and I get 10. You don't want to pick any of those as guesses or as answers you do without doing the work. So if you were guessing on this question, you would guess either 5 or 6. Now we're not going to guess on this question. We're going to work through it. So how the heck are we going to deal with it? Remember again to look for patterns in the problem. So we've got either a single letter or by a pair of 2 distinct letters. So there's only 20 factories. If we start to write up the pattern, we might notice it before we get to the end, but even if we don't, we only have to go through 20 factories. But we want to make sure that we're being methodical and looking for those patterns one at a time. So what's the first letter that you could use to represent a factory? Well, the first letter is A. That represents one factory. That's fine. That doesn't create any 2 distinct letters because they're distinct, I can't use A and A. Now, what if I add B? Well, I then could have the 2-letter pattern of A and B. And you'll notice if I start with A, I get 1 factory, but B adds 2 factories. I could have the single letter B or the pattern of A and B as a 2-digit code. Now, maybe you're starting to see the pattern emerge, or maybe you need to go to the next letter. What happens if I add C? Well, I get the single letter C, but I also get 2 new double letter patterns because I can combine that C with an A or I can combine that C with a B. And you start to notice that with each additional letter, you add that many more factories. So the second letter adds 2 factories. The third letter adds 3 factories. You can continue on the pattern. D would add 4 factories, and I just noticed that this one should say BD, but it still adds 4 factories. E would then add 5 factories, and if I count them, I've got 5 plus 4, which is 9, 10, 11, 12, 13, 14, 15 factories available by E, so that's not enough yet. And then if I add F, then that adds 6 more factories that I can name. So if I have 6 plus 5 is 11, plus 4 is 15, plus 3 is 18, plus 2 is 20, and 21 factories. So if I use the letters A through F, I will be able to label 21 factories, which is the number. I need to label 20, so 21 is 1 greater. And how many letters do I need? 1, 2, 3, 4, 5, 6. Thus, 6 is the answer to this tough question. At first glance, you might think, oh, I need counting techniques. I need to work within permutations and combinations. But really, looking for patterns and being methodical can make a problem seem much easier than attacking it with strict mathematical formulas. A lot of the time, the way to handle tough math is to handle it the way you would in the real world. By looking for patterns, by drawing pictures, and by trusting in yourself that you can solve the problem within the time. You just have to start. So, what have we learned today in today's lecture? What we've learned is hard. If you read it and go, oh, I didn't study this, that's probably not true if you have done a comprehensive job of studying for the math. It's probably just a problem that's been designed to look hard. Remember, hard math is not harder concepts. It's concepts that are put together with multiple steps or written in unusual ways. Secondarily, we've noticed on a bunch of the problems that I did today, you should never do unnecessary algebra. You can plug in numbers instead. Now, you are always welcome to do the solution both ways in your study sessions at home. When you're reviewing a problem, if you like algebra, you can write it up the algebraic way. But work on working with the flexibility, because plugging in numbers helps to avoid wrong answers and also helps to avoid silly mistakes. If you don't know how to work a confusing problem, use the words you know. Identify those words which tell you what the concept is and pull up the definitions or the formulas of that problem and help that to give you a start to the problem. If there are no words that you know, if you feel uncomfortable or that it's an unusual topic, then remember to look for commonly tested concepts, looking for the concepts of maybe common quadratics or factoring or even positive, negative, or some of the commonly tested concepts on the GMAT. If the concept doesn't seem familiar, then remember what the GMAT tests. This is kind of a break of the one before, or a part of the one before. If you recognize the words but don't understand the concepts, you might look for those commonly tested concepts. If the words seem odd, then remember what the GMAT tests and apply those same common concepts. If the problem seems long, see if you can be methodical and look for patterns. And finally, if you're really uncertain about how the math works, you might want to try a simpler example to make sure that you're not making a common error that the GMAT is prepared for and has an answer ready for you to make that common mistake. So that's the best way to prepare for the hard math and to work within some of the hard math problems. I think by showing you some of these problems, we've shown you that the techniques can work and can. So, beyond these small tips that I've given you in the past hour or so, what's the best way to prepare for hard math and actually for the whole GMAT? It's to partner up with a company that knows this so that you're not reinventing the wheel. Work with somebody who understands the small universe of topics tested on the GMAT and can provide the basic approach for each one of those topics. Also, work with a company that's going to provide you strategies and techniques, not just solution strategies, but also strategies for how to work the problem when maybe things aren't going as perfectly as you'd like. We've all seen those GMAT problems that are that brick wall, and you want to find somebody who will help you to develop strategies to get over that brick wall so that you can achieve your highest score on the GMAT. So I work with Princeton Review, and I highly recommend our company. We certainly have years of research and development into each one of those topics and can provide all of the necessary information to help you achieve your best score on the GMAT. How do we do that? Well, we have multiple options. Private tutoring is our favorite option for working one-on-one, going through the problems, and working on your specific strengths and weaknesses. In a private tutoring environment, you'll get all of the strategies and techniques, you'll get all of the math knowledge and understanding, but with as well as all the verbal, with a focus on your particular needs. If private tutoring isn't something you can do, you can visit one of our classroom courses. The great thing about our classroom course is that it's limited to 4 students. That means you're not going to be overlooked and you're going to be asked to actively participate in class every day. There's 27 hours of class, which breaks down to 9 3-hour classes. So you're going to plan about 2 months, maybe a little more, to study, which has been proven to be about the right amount of time to study for the GMAT. It's going to include 10 practice exams, hundreds and hundreds of drills and specific problems to help work on every concept and every strategy and technique. If you can't make it to a classroom course or you prefer the flexibility of live online, we also have that option. This is broken into 13 2-hour sessions, so the classes are going to run a little bit longer in prep time, which might be nice. But please know this isn't a recorded online. This is a live teacher interaction. Every student has a headset and microphone, and every student will be able to participate within the chat environment. So this is going to be as close to a classroom course. We're all just going to be having headsets, and you can come to class in your pajamas. You get all of the same computer content you'd get in the classroom course. Now, with any of these 3 options, the Princeton Review also offers 30 hours of tutoring with a master GMAT instructor online. These are 30 scheduled hours during the week. You can hop on and ask any GMAT question of a master GMAT teacher and be walked through the solution. You can use one of those hours or you can use all 30 during the week. They're spread out. There's plenty of hours on the weekend as well as hours on weeknights and weekday mornings and afternoons as well. This is one of the great services we offer that will really help to push your score to that next level. And then finally, if you've studied on your own and you're not really in need of a full course, but you do need that hard math boost, you want a little more than this lecture presented, we have our hard math workshop. It's 1 hour of a live online workshop, which means you work with a live teacher. It's dedicated to tackling the toughest math problems on the GMAT. Contained with the course is over 300 additional hard math questions, and you get to listen to all of the lectures recorded at your leisure. This course is included with the purchase of a full course, either classroom, live online, or live tutoring. So if you take one of the 3 options above, you get the hard math workshop for free, but if you don't want to necessarily commit to a whole class, you can just take the hard math workshop. And now, for the benefit of coming and attending this lecture, I appreciate you spending your hour or so with me. For watching this session, you can get $200 off a small group instruction classroom course or a live online course. Our typical discount for working with one of our partners is $100, so this $200 off is a special deal that only comes around once in a while. That's going to expire December 31st. Or if you just want to work with the hard math workshop, we're giving this one time only $50 off the hard math workshop, and that expires December 31st. If you'd like to receive any of those offers, email this email, anthony@review.com. He'll provide you with a unique promotional discount code, and then you can go ahead and enroll at princetonreview.com and enter your unique promo code. So it's a great offer. It's a good time to start studying for the GMAT, whether you're getting ready to put the applications in or you're thinking about business school in the next year or so. It's certainly always beneficial to get the GMAT out of the way as early as possible. So thanks for sticking with me through some of the hard math. I know that this can strain some of your brain, but I hope you found it useful and helpful, and I look forward to answering your questions in the Facebook chat at the end of this session.